Okay, this podcast is the second one that's dealing with Section 8.4 in our textbook on areas of triangles. This particular one's going to address questions 16 and 18 on page 457. I picked these two questions because they're probably the two hardest ones on our homework. And I already drew them in Sketchpad here. Here's the first one, question 16. What they want us to do is find the length of CB here, this right side of this triangle. And to do that, they give us the measurements of AB, CF, and AW. The hint in order to do this, if you saw it in parentheses there, they said compute the area of triangle ABC in two different ways. The way this is going to work really is because if you look, these two segments that I've colored black here, that's the base and the height of this triangle. So if I plug it into 1/2 base times height, I've got all the information I need. I'm going to get an answer. And then when I get that answer, I'm going to use that with AW as my height then, and I can solve it doing a little bit of algebra, figuring out what CB is. And I got that in Word here, and you'll see what I'm talking about. Okay, here again, area of triangle ABC I've got is 0.5 or 1/2 times the base times the height, which you already know. Okay, and what that area is, it's 1/2 of how long AB is times how long CF is. Plugging in the numbers, what they got here, it's 0.5 times 8 times 6, which is 24 square units. So the area of this lovely triangle here is 24. Now we're going to take that information and the fact that AW is 7, and we're going to solve kind of backwards here and figure out what CB is. Okay, so what I'm going to do is where I have area of triangle ABC, that equals 0.5 times CB, which is my new base, times AW, which is my new height. Still has the same area though. So I've got the area of triangle ABC, which we already found using the information they had given us before. That's 24 square units. We know the length of AW. That's 7. But I'm trying to figure out CB. So what I'm going to do is, okay, from this step to this step, I just took this to get rid of the 0.5 and multiplied both sides by 2. So I have 48 equals CB times 7. And then divide both sides by 7. I get CB equals 48/7, which is about 6.86 units. And that's how it's done. Found the area one way, got the answer, plugged it back in the formula, used the different base and the height, and figured out CB that way. Okay, second question is question 18, and because it says proof, I'm going to guess that most of you won't even want to look at it or skip it and say, hey, you'll do it in class or something like that. But it's not too bad. It's not one of those we're not going to do like a formal 2-column proof here. Because what they're saying is we want to prove that the area of this kite looking thing kind of looks like a kite, doesn't it? Okay, well, they said the area of this thing is 1/2 times the product of its diagonals. So 1/2 times the length of AC here times the length of BD. Alright, how we're going to do that is we're going to find the area of this big triangle on the top, the area of the big triangle on the bottom, and add them up. And that'll be my area of ABC. You'll see where we're going with this, because we said we want to prove that the area of this is 1/2 times AC times BD. Okay, so going back in a Word here, I already had this done for you. It says we're using the additive property of areas. All that is if you wanted to figure out the area of some object, you can find the areas of the shapes that make up that object and add them together. And then we're going to use the triangle area formula also. So again, like I said before, the area of ABCD, which I have here, equals the area of triangle ABC plus the area of triangle ADC. Going back here again, here's ABC on the bottom, ADC on the top. Okay, substituting some stuff in here. The area of ABC is 0.5 or 1/2 times AC times BE. AC here, AC is the base. BE is the height of that triangle. So that's where that comes from. Okay, the area of ADC is 0.5 times AC times ED. Again, AC, look, it's the base of both of these triangles actually, the one on the big one on the top and the big one on the bottom. So it's going to be 1/2 times AC times DE. Okay, going back into here again. If you look, both of these little chunks have a 0.5 AC. There's one there and there's one here. So I'm going to factor that thing out. So I'm going to pluck that out of both of these, and I'm going to write whatever's left over in parentheses. So I got 0.5 AC times the quantity BE plus ED. Well, what in the heck is BE plus ED? Look back at the figure. BE is the height here, ED is the height here. So what these two added up equals is actually the length of BD. Okay, and then so I've got 0.5 times AC times BD. That's the area of that quadrilateral. Well, you know what? AC and BD are the diagonals. There's our proof. Again, it's not one of those fancy 2-column ones. We just kind of reasoned our way through it. Alright, and then for part B there, it says to which of the following types of quadrilaterals does the result in part A apply? Well, it applies to everything on the left side of the quadrilateral hierarchy. Start with a square, because that thing has perpendicular diagonals, and work your way up. We've got diagonals, or squares, we've got rhombuses, and we've got kites. That's it.